An estimated 2 billion tons of waste are dumped on the planet every year, and is still expected to grow to over 3.4 billion by 2050. This is worsened by the COVID-19 pandemic, with the plastic pollution from medical wastes, such as single-use surgical gloves, face masks, disposable personal protective equipment or PPEs, that end up in landfills and waterways. From production to after use, these materials are reminders of the linearity of current production models, and the toll that they contribute against the environment. With the end of the pandemic not in sight, and the new normal that irreversibly affects our protective wear and lifestyle, innovations towards circularity and inclusivity in handling these problems are prioritized. The Philippine Textile Research Institute of the Department of Science and Technology, as the lead textile research and development institute, actively undertakes R&D as drivers and enablers of integrated and sustainable textile processes towards responsible emerging and advanced technologies and products through the use of natural fiber blended textile materials, bio-based resources, and byproduct recycling and valorization. The use of knitted and woven fabrics as protective wear can be enhanced through smart tech solutions. These are smart textile finishing technologies that enable textiles to be responsive to external stimuli. These finishing technologies do not only impart aesthetic benefits to the fabric, but more so functional properties, to improve the performance of the materials in response to its evolving application. In partnership with Custom Made Craft Center, which is the marketing arm of the Non-Timber Forest Products of the Philippines or NTFP, the DOSTPH will provide these enabling technologies to different weaving communities in the country. Through DOST's Science for Change program, the project under Cradle, or Collaborative Research and Development to Leverage Philippine Economy entitled Community-Level Functionalization of Hand-Woven Cordillera and Mindoro Textiles for Creative Protective Clothing, will develop functionalized indigenous hand-woven washable face masks as a sufficient alternative for general public consumption. The use of hand-woven fabrics for PPEs will create the value chain within the community and will empower the countryside workers, cooperatives, associations, and home-based weavers to play an active role in the provincial response against COVID-19. At the same time, it will provide a consistent flow of income at this time where there is a low demand for their conventional handloom woven products. Usage of these hand-woven materials will also lessen the plastic waste accumulation, which is currently the negative environmental impact of the disposable PPEs. Aside from finishing technologies, the production of non-woven textiles is also an intervention of the Institute in combating health and environmental problems. Non-woven textiles are engineered fibrous assemblies, which have been designed to provide structural integrity through physical, thermal, or chemical means. Fibers can be arranged into a web through dry laying, wet laying, or spun laying. Natural textile fibers such as banana, abaca, pineapple leaf, and bamboo can be primarily used in dry laying and wet laying forming processes. The DOSTPTRI established the Non-Woven Textile Innovation Center, which shall serve as the core and central facility for the conduct of research, development, and innovation for the diversification of the Philippine textile industry. Non-woven production lines, specialized non-woven testing equipment, and an R&D lab will be situated here. The DOSTGIA-funded program entitled Diversification of Philippine Textiles through Non-Woven Innovations aims to utilize local natural textile fibers for the production of non-woven textiles for technical applications such as automotive linings and air filtration systems. Non-wovens cover many applications, ranging from health and hygiene to interiors and upholstery. This is made possible by the various processing methods that are used in the production of non-wovens, which grant different properties that are suitable for each application, such as heightened thermal properties for insulation and increased permeability for fluid filtration. As a quick response to the COVID-19 pandemic, the program intends to deploy products that could help alleviate the rapid transmission of the coronavirus in workplaces and office settings. Needle-punched sanitation mats, wet-laid mask filters, and non-woven aircon filters are the products to be developed by DOSTPTRI. These promote the versatility of natural fiber-based non-woven textiles in any intended end use. The program also intends to develop finishing technologies for non-woven textiles for the production of an alternative leather material. The developed vegan leather is intended to be used for wearables, such as footwear and bags. The use of natural-based materials in the production of nonwovens will alleviate environmental concerns in unsustainable leather and textile processes, and improper waste management. The DOSTPH, through the Nonwoven Textile Innovation Center, will also enhance its expertise in the remaining nonwoven processing. Spunlace. Spunlace nonwovens can be produced through petrochemical-based raw materials, and are processed through the blowing of hot air, or melt blowing, or through thermal bonding, or spun bonding. These nonwoven materials are commonly used for a wide range of applications, such as in the packaging, agro-industrial, geotextile, and medical fields. However, with its variety in applications, comes its increase in contribution to global plastic waste. Spunlace nonwovens are the main materials used in single-use surgical face masks, which now pose a threat to land and marine ecosystems due to improper waste disposal. The Spunlace Nonwovens R&D program of DOSTPH entitled Sustainable Melt-Blown and Spun-Bonded Nonwoven Textiles aims to provide alternative raw materials for the production of spunlace nonwovens through byproduct utilization and the use of biopolymers. Feed materials for spunlace nonwoven production will be developed from bio-based sources, such as agricultural wastes, and recycled sources, such as used plastic bottles. The main applications that the projects aim to target are the packaging industry, in tea bags and coffee filters, and the agro-industrial and geotextile industry, through the production of crop covers, geodesic domes, mulching fabric, and other geotechnical products. The produced spunlace nonwovens can also be layered with one another to produce functional composite nonwovens, through the synergistic behaviors of each fabric, to produce textile for a suited application. These nonwovens can also be treated to provide UV protection, increased barrier and antimicrobial properties, mechanical and structural integrity, among others. This program, with its constituent projects, addresses three needs. First, the lack of local availability and capability. Second, cheap yet substandard textile products without testing and evaluation. And last, the lack of proper waste management and reusability guidelines for spunlace nonwovens. The textile processing sector provides an integral component in modern society and structure, and is known for providing human comfort and sustainability. The desire for better garments and apparel is the main factor driving this application sector. However, the textile industry is also dynamic, going beyond comfort and aesthetic trends. Today, the emergence of technical textile products has become of necessity to us, especially against hazards and infections. The good news is, researchers and innovators everywhere make moves to meet the world's biggest challenges head on.